Sketch the graph of f of x, which is defined as a piecewise function. It's equal to 3 if x is less than -2. F is equal to the opposite of x plus 1 if the absolute value of x is less than or equal to 2, and it's equal to -3 if x is greater than 2. Well, let's graph this piecewise function in 3 pieces. First, as we trace along the real line, here's our x and here's our y, we see that for any x less than -2, f's value is supposed to be 3. So for all of the values of x that are less than 2, we need to have a value of f that's equal to 3. And so we can sketch that graph this way. We'll use an arrow to indicate that that pattern continues to minus infinity. We've graphed this piece of the piecewise function. Now the next piece of that function represents the value that f should take on for any x that has an absolute value less than or equal to 2. Now if we take the absolute value of x less than or equal to 2, the interval of values for which that holds is from -2 up to +2. The absolute value of any of these x's would, between -2 and 2, would produce an absolute value less than 2. So we need to consider the portion of the real line from -2 up to +2 and find out what the values of f are on there. That is, what's the graph of f going to look like. Well, for that portion of the real line we have y equals -x plus 1. That's graphing just this piece of the function. That is the graph of a straight line that has a y-intercept of 1, so I'll mark that point, and a slope of -1. So a slope of -1 will go over and down, or left and up, and if we count out points we see that -1, 2 is on there, and -2, 3 is on there. Now this circle that I had indicated here before was open because I wasn't working with the domain at -2, I was working only with numbers less than -2. It turned out that I was able to fill in that circle by using the second piece of the definition of f. I can continue getting a sense of the shape of this linear segment from -2 to 2. We can see by counting over and down 1, counting off the slope, that the values of f are roughly shaped like this. We ought to 2, -1 as the lowest end point for that portion of the graph. Now beyond x equals 2, and we've just finished the second piece of the piecewise function, beyond x equals 2, the value of f is supposed to be -3. So -3 is going to be the dominating y value from here on out. I've used an open circle there to indicate that the value of f at 2 is not -3. It's actually the solid circle that I filled in. It's -1. There's a jump in this function, and that's not uncommon for piecewise functions to have jumps in them. And the only thing to do to complete this is to indicate the remainder of the real line, mark those off, and make sure you put an arrow indicating that we're going to be at -3 for the duration of the real line as we move towards positive infinity. This is the graph of y equals f of x as defined above.